Hey folks, I'm Arjun Iyer, and I'd like to share an exciting new development in our effort to take advantage of the BRICS digital platform by incorporating interactive, enhanced clinical images. We call this project Use Case 2, and we'd like your help to make it happen. Labels and arrows are helpful up to a point, but are often unable to adequately draw attention to the key elements of an image. In this H&E stain of a vessel with atherosclerosis, you can see that while you're pointing out the foamy macrophages, they kind of get lost in a sea of H&E stain. But by highlighting key elements of the image on mouse over, we're able to make these elements visually distinct from the background, even to the untrained learner, while remaining minimally obtrusive to the underlying image details. On an X-ray, you can see that the grayscale kind of obscures some of the structures of the mediastinum and makes them difficult to parse out. But again, the colored overlays help you pick out the individual elements. You'll notice on the CT that we like to make the color schemes intuitive and consistent from image to image. The lungs are still purple, the aorta is still pink, the trachea is still sky blue, and the pathology, whenever possible, is going to be bright red in order to draw the attention of the student. Even on an electron micrograph, where the borders are pretty crisp and clearly defined, the colored overlays help bring the image to life and make certain elements more visually cohesive. For example, the foot processes are the same color as the podocytes, indicating that foot processes are in fact offshoots of the podocyte. Now, because this is intended primarily for use by preclinical students who are learning about these for the first time, we label the images for first-pass learning. But what makes this a real game changer is the ability to train students to interpret images like real clinicians with the interactive quiz mode. And this transforms the experience into active, clinically applicable learning. On the CT of diverticulitis, for example, a student can attempt to pick out and identify the individual elements like a real radiologist and receive immediate feedback on their interpretation. I like this image in particular because it provides a great example of fat stranding, something that anybody who reads CTs is going to need to be able to pick out immediately. And we don't stop there. We're not limited strictly to identifying structures, but also the associated features that help real radiologists and pathologists both localize and characterize pathologic findings. In this stain of giant cell arteritis, when you mouse over the brown patch, not only does it identify it as a granuloma, it also causes the giant cell to pop out in red, which is a key feature to characterize this as granulomatous inflammation. When you mouse over the tunica intima, it also causes the internal elastic lamina to show up. And not only is this key to understanding that the internal elastic lamina is the defining boundary between the tunica intima and the underlying tunica media, but when you mouse over, you also notice that the internal elastic lamina is actually discontinuous because it's been partially obliterated by the granulomatous inflammation. I'll show you one final example. On this MRI of an acute right MCA stroke, the pathology is actually fairly obvious to even a non-clinician, I would think. But rather than getting distracted by the giant bright white patch on the right side of the brain, a real radiologist would be busily trying to identify other characterizing features. When you mouse over, the student's attention is immediately drawn to the midline shift away from the lesion and the compression of the ipsilateral lateral ventricles. And this completely changes the clinical picture from something that's going to cause dense hemiparesis to something that can actually cause brain herniation and death. This is a person who might actually need a decompressive craniectomy at some point. So, Use Case 2 is a potential game changer in teaching students how to interpret clinical images, and is one of the ways we're hoping to revolutionize digital learning through multimedia in the coming year. We hope you'll help us achieve that vision.